Hello everyone. Today we're going to talk about significant figures and calculations involving significant figures. Now, if you're wondering what significant figures are, if you have ever typed an expression into your calculator and then received an answer that has 6, 7, 8, or 9 decimals, and you're unsure of how many to keep, there's actually a way to figure that out based on the numbers that you entered and what type of calculation you're performing. That's one of the things that significant figures helps us out with. The other is measurement. So when we're taking measurements in science, it's important that we report our answer to the correct number of digits. And that number of digits is going to be based on the precision of the instruments that we're using. So we can't just pick any number of decimals or always choose 2, but instead we're going to use this method to identify the correct number of decimal places or the correct number of numbers to keep when we perform a calculation. So let's take a look at our definition for significant figures. So I wrote here that significant figures in a measurement consist of all of the digits known with certainty plus one final digit which is somewhat uncertain or estimated. So here we have a cross section of a graduated cylinder. If you look, the meniscus, the bottom part of this curve here, falls right along this line here. Now, if you look at the number of graduation marks between 70 and 80, you'll see that these are each worth 1 unit. This is most likely measuring in milliliters. So we would say that this measurement or this meniscus has a volume of 71, 72, 73. And because it's slightly above that line, so if you notice the line is here and there's a basically very, very thin layer right above it, we might say 73.2 milliliters. We are adding that one estimated digit. Now, in order to add that one estimated digit, you need to know exactly where 73 is and where 74 is, and realize that it falls closer to the 73 milliliters and further away from the 74 milliliters. This part is our estimated digit. Okay, let's take a look at the example on the right. In this case, if you look at the graduation marks on this, you'll see again that we have each one counting for 1 milliliter. So here's our 30 milliliter mark. Here's our 40 milliliter mark. Each one of these is 1, and this is our 35 right here. So a meniscus that's falling in between these two lines, so this is our 35, this is our 36, and our 37. So we know that it's more than 36, but less than 37. So we can put in there 36 point, and you could give it an estimate. This part is always going to be up to you. So 36.6 milliliters. So that means it's higher than 36, but less than 37. Okay, perfect. Let's take a look at the next slide. So in the next slide, we have this picture of a backyard pool. And it says that the swimming pool contains 10,000 gallons of water, which we're going to learn how to do this later in the chapter, which when you convert it turns out to be 37,900 liters of water. Now, to that 37,900 liters of water, we're going to add 48 milliliters from this graduated cylinder over here. Now, here is my point. Is it okay to suggest that there are exactly 37,900.048 liters, that's converting milliliters to liters, of water in this pool? And the answer to that is absolutely not. You could never report the volume of this pool to this level of precision. And the reason is, yes, you might have added that last 48 milliliters really precisely using the graduated cylinder, but you certainly didn't add the original 37,900 liters to that level of precision. So you can't report an answer that suggests that you know what the volume is to this level of accuracy when you really don't. You don't have any idea how many milliliters of water were in the original 37,900 liters. So what we're going to do now is we are going to take a look at the rules that govern how many significant figures you can use in a measurement, and then we'll talk about how many significant figures you can keep in a calculation. So if we look at this, this is straight out of your textbook. This exact image appears in your textbook. So it says the rules for determining significant figures. So the first rule, zeros appearing between non-zero digits are significant. Okay. Zeros appearing in front of all non-zero digits are not significant. Okay. Zeros at the end of a number and to the right of a decimal point are significant. Okay. And zeros at the end of a number but to the left of a decimal point may or may not be significant. So if a zero has not been measured or is estimated but may just be a placeholder, it's not significant. But a decimal point placed after the zeros indicates that they are significant. So who does not understand this, right? So clear. I'm kidding. So what I did was I found a different way to talk about significant figures that I'm going to teach you right now. This may seem a little foolish at first because it involves a silly drawing, but I promise you this is a much easier method that I'm going to teach you than you trying to memorize these 5 rules. So here's what I'm going to draw for you. Tell me when you know what it is. So this is the United States of America, or as best as I can draw the United States of America freehand. So on this side of the United States of America, we have an ocean. It's called the Pacific Ocean, but we're only going to use the P part here, and we're going to have this represent present, and I'll explain what that means. And on the other side, we have the Atlantic Ocean, but over here, we're going to have this represent absent, and let's say we're about somewhere around here. So what we're going to do in each of our examples is we're going to ask ourselves a question. Is the decimal point present or is it absent? If it is present, we're going to count in this direction. And I'll explain what that means. If the decimal point is absent, we're going to count in this direction towards the word absent. Now, what we're going to do, let's take a look at these couple of examples here. So if we look at the first one, we have a decimal point. It's present. So we're going to count going in this direction. And we're going to count. We're going to start all the way on the right side here. We're going to go all the way to the left. So this has 1, 2, 3 significant figures. So we're going to write 3 significant figures. When there is no decimal point, like in our second example, we're going to count in this direction because the decimal point is absent. So we're going to start over here and we're going to count 1, 2, 3, 4, 5. This has 5 significant figures. Seems pretty straightforward at this point. Okay, the next one. There is a decimal point present. So there's a decimal point. We're going to count in this direction again. And we're going to stop counting when there's only zeros in front of us. So I'm going in this direction. I'm going to count 1, 2, 3, 4, 5. And now I'm going to stop at 5. Because once I get past the 9, everything in front of me is a 0. This 0 is a placeholder. This has 5 significant figures. Okay, let's look at our next example. Again, we're going to count from the right side to the left side. We start here with the 9, that's 1, and that's it. We stop after that because everything in front of the 9 is a 0. That means this has 1 significant figure. Now, we're going to learn when we start to look at calculations that doesn't mean you can forget about the other zeros. That doesn't mean that 0.0009 suddenly becomes the number 9. It just means that those values that are in front of it, those zeros that are in front of it, are not considered significant. They're there, they're placeholders, they are important, but they're not significant in terms of doing a scientific calculation, and you'll see that explained. Okay, the next one. Again, we have a decimal point. So again, we're going to say, we're going to count in this direction, so we're going to say from right to left, and we're going to start all the way over here on the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this case, there are 10 significant figures. Okay, let's take a look at the number 2000. Written like this, the number 2000 does not have a decimal place. So in this case, we're going to count from left to right. We're going to say this is 1, and then we're going to stop counting because all of those are zeros. So this has 1 significant figure. Now, in the next example, we have the number 2000, but now we have a decimal point at the end. So now we're going to count in this direction. So we're going to start on the right side and count 1, 2, 3, 4. 4 significant figures. Now, let me explain the difference between the number 2000 and the number 2000 that's followed with a decimal point. If you said to someone, I walked for approximately 2,000 feet, you would report it like this, 2,000. If you said, I walked for 2,000 point or 2,000.0 feet, that is a much more precise number, and you would report it like this. That means someone was out there with a tape measure measuring exactly how far 2,000 feet was, as opposed to someone saying, I walked about 2,000 feet. So the significance part shouldn't change the magnitude of the number. It doesn't make 2,000 suddenly 2 or 200,000 or any other number. It doesn't change the size of the number. What it's changing is the perception with how you measure that number. Not measured very accurately, measured very accurately. Okay, the last one that's all the way at the bottom that might be a little difficult to see, let's bring that down a little bit, is 85.00. So in this case, I have a decimal point. So I'm going to go in this direction again. 1, 2, 3, 4. The reason why I don't stop counting at the zeros over here is because there are non-zeros that are still in front of me when I'm heading in this direction. So I have 4 significant figures here. Okay, what we're going to do on the next slide is we're going to try a few of these on our own. Okay, so at this point, I'm going to put up 5 examples. I would like you to try these 5 examples on your own and record the number of significant figures based on the map of the United States and our positioning of both the Pacific and the Atlantic Ocean. So I'll wait around for a little bit, and I would like you to try and complete these 5 problems. Okay, let's take a look at them. So if we look at the first problem, 28.6, the question is, does it have a decimal place? The answer to that is yes. So if the decimal point is present, remember we're going this way. So we count, starting on the right side, going to the left side, stopping when there's only zeros in front of us. So we count all 3. This has 3 significant figures. In our second example, there is a decimal place. So we count this way. 1, 2, 3, 4. You count the 0 because as you head to the left, there are still non-zeros that are in front of you. So we wind up with 4 significant figures. In example number 3, there is no decimal place. So with no decimal place, we count in this direction. By the way, this one was up here. In this direction, and we're going to count 1, 2, and then we're going to stop because everything after the 1 is a 0. So we count, and there are just 2 significant figures. It's basically saying a measurement of 910 is not as precise as maybe 907. So something that would have 3 significant figures. Okay, the next one, there is a decimal point. It's right here, so we're going to count in this direction. We're going to stop counting when there's only zeros in front of us. 1, 2, 3, 4. We're going to stop here because everything going this way is a 0. So this has 4 significant figures. And then finally with the last one. Again, we have a decimal place, so we're going to count in this direction. We're going to start over here. These zeros get counted because there's non-zeros in front of them. So 1, 2, 3, 4, 5. And we stop because everything to the left of that 6 is a 0. So we stop at 5 significant figures. So 5 of those numbers are important. These guys are considered placeholders, so they don't count as part of the measurement. They're like the zeros that would sit out in front of the number 2000. So this part is important, but if I wrote zeros over here, they would not be important. Okay, I'm going to pause for a second. Hopefully you have a good understanding of this. You can rewind this if you would like and try and listen to it over again. We're going to move on to the next slide. Okay, so what I would like you to do at this point is to open up the document on Schoology called Significant Figures Practice. There are about 25 examples of this on there. I would like you to try that on your own and submit it. I will post the answer key to this as well so that you can check your answers. And I'm also going to share a link to another place, another resource where you can practice doing this. So I'm going to pause for a second, and then we're going to go over this assignment. Okay, so here we are looking at the significant figures assignment. Now I know some of these numbers are incredibly small, especially on this video, but that's okay because I'm hoping that you actually have attempted the assignment and have the assignment open right in front of you. So what we're going to do is we're going to go through the answers here, and we are going to write down the correct number of significant figures. So for question number 1, we have the number 2.3. 2.3, there is a decimal point, so we're going to count in this direction. That has 2 significant figures. In question number 2, the number is 4,053.4. There is a decimal point present, so we're going to count in this direction. 1, 2, 3, 4, 5. 5 significant figures. Question number 3, there is a decimal point present. Again, we're going right to left. Again, we have 5 significant figures. Question number 4, we have a decimal point. We're going right to left. This time we have 4 significant figures. In question number 5, we have a decimal point. We're going to count all the way from the right side to the left. So we wind up with 1, 2, 3, 4, 5, 6, 7. 7 significant figures for number 5. Question number 6. We have 0.023000. Decimal point is present. Same thing up here. So we're going to count 1, 2, 3 zeros, then the 3, then the 2. We're going to stop counting after the 2 because everything to the left of the 2 is a 0. So we wind up with 5. Question number 7. No decimal point present. We're going to count from left to right. That has 3 significant figures. Decimal point present in number 8. So we're going to count from right to left. 1, 2, 3, 4 significant figures. Here we have the number 2000. Number 2000 has no decimal point, so we're counting from left to right. We stop after the 2 because everything after that is a 0. It's a placeholder. Okay, the number is 4,000.0. There is a decimal point, so we're going to go in this direction. We're going to count all of those zeros and the 4. So we'll wind up with 5 significant figures. Here's the number 0.00002. So there is a decimal point present, so we're going to count in this direction, but only the 2 gets counted because all of the others that are in front of it are zeros. Now, the next one, we have the number 2 billion. We have all zeros behind it. 1 significant figure. We're counting in this direction. Everything after that 2 is a 0. I hope, at least that's what it looks like from right here. So that would have just 1 significant figure. The next one, number 13. We have 990.001. So in this case, there is a decimal point, so I'm going to go in this direction, and I'm going to count all 6 of those. Next one, 14. We have 0.00040. There is a decimal point, so we're going this direction. We have 2 significant figures, this one and this one. The next one, number 15, we have a decimal point. We're going in this direction. 1, 2, 3, 4, 5. Stop right there because everything in front of you is a 0. 5 significant figures. Number 16. Again, we have a decimal point, so we're going in this direction. 1, 2, 3, 4, 5. Stop counting after the 2. The next one has a decimal point. We're going in this direction. All of these digits are going to be counted. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up at the top, number 18, there is a decimal point. So we're going in this direction. That's 5. Number 19, there is a decimal point. So we're going in this direction. That's 4. Number 20, there is a decimal point. So we're going in this direction. We have 1, 2, 3, 4, 5, 6. There is a decimal point. Going in this direction, 5. Decimal point, this direction, 1, 2, 3, 4, 5, 6. There is a decimal point. We're going in this direction, 1, 2. Next one, there is a decimal point. We're going in this direction, 1, 2, 3, 4, 5, 6, 7. Here we go, 1, 2, 3, 4, 5, 6. And 52.0 has 3. All right. Take a minute, pause the video if you need to, try and figure out if you got any of these wrong and what happened. Remember, if the decimal point is present, we count from right to left. If the decimal point is absent, we count from left to right, and we stop when only zeros are in front of us. So if it helps, picture yourself as like a little character that's walking along this number and you're going in this direction. When everything that's in front of you, depending on whether you're going left or right, when everything that's in front of you is a 0, stop counting and don't count that 0. Okay, what we're going to do now is we're going to move forward and we're going to take a look at how to use significant figures as part of calculations. Now, this in some cases might actually help this make a little more sense to you instead of just looking at the numbers in isolation. So let's take a look at this. I wrote, what is the answer to this calculation? So as I mentioned right at the beginning of the video, sometimes we do a calculation like this one, 15 divided by 3.47. And we get a whole slew of decimal places. And the question becomes, well, how many of those decimal places should we actually keep? How many of these numbers should we actually keep? And these are all of the different possibilities. These are all of the different possible answers for what we could write down when we get something like this in our calculator. I'll tell you, the actual answer is this one right here. And what we're going to learn next is how to figure out that. How do I know that 4.3 is the answer, not any of these other possible combinations? So let's take a look at the rules for working with significant figures. Okay, so as you can see here, I have the rules for adding and subtracting, and it's interesting because the rules for adding and subtracting with significant figures are different than the rules that we use for multiplying and dividing with significant figures. So, and I know this is a little blurred out right here, so I'm just going to read it to you. It says, when adding or subtracting decimals, so we have numbers with decimals on the side, the answers must have the same number of digits to the right of the decimal point as there are in the measurement having the fewest digits to the right of the decimal point. So if you look at the two numbers that I have there, I have 5.44. 5.44 has 2 Now, I'm not talking about significant figures here. We're talking about decimal places. So 5.44 has 2 decimal places. The number 2.6103 has 4 decimal places. So we have 2 choices, 2 or 4. Which one is less? So obviously the 2 is less. So that means that our answer can only have as many decimal places as the number that had the fewest. So in this case, we can only keep 2 of these decimal places. So I'm going to take a look at the 2. I'm going to look behind it, 2.829, and I'm going to get 2.83 meters. This is my final answer reported to the correct number of decimal places. We can't show an accuracy of 4 decimal places when one of our numbers only had 2 decimal places. This goes back to what we were saying before with the pool. You can't report the volume of the pool to 3 decimal places when the majority of the water that you added to it, you did not measure that precisely. So you can't report a distance of 2.8297 meters when one of the numbers that you used to get that, you only measured to 2 decimal places. All right, so let's take a look at, so now we're going to take a look at the rules for multiplication and division. I'm going to use something similar like the 2 same numbers that I used before, but this time we're going to be multiplying them together. So the rule states, when multiplying or dividing, the answer must have the same number of significant figures as there are in the measurement having the fewest. So now we're going to go back and we're not going to look at decimal places. We're instead going to look at significant figures, just like we practiced in the very first part of class. So the number 5.44, there is a decimal place, so we're going to count in this direction. This number has 3 significant figures. The number 2.6103, there is a decimal place, so that number has 5 significant figures because I count all of these. So now you identify which of these 2 is the least, so that's 3. So that means your answer can only have 3 significant figures. So this is the part that has been extremely challenging for some students. We need to get this number so that it only has 3 significant figures, but we don't want to change the magnitude of the number. So we don't want to make something that's 14 suddenly just a decimal. So we have to keep this part. So you keep, when you decide this, you start from left and you work to the right. So we have to keep this, we have to keep this, and here's our 3rd significant figure, and you're going to look behind it. It's a 0, so you're going to leave it alone. So we're going to wind up with 14.2 meters squared. Hopefully that makes sense. We look at whichever one had the fewest number of significant figures for multiplication and division, and that's what we use to engineer, to edit our answers so that it has the correct number of significant figures. So just for fun, let's go back to that example that we had earlier with the 4.3. So if I go back to that slide, I had said at the bottom that this was our answer. And the reason is this number 15 has 2 significant figures. No decimal place, so we would count from left to right. This has 2 significant figures. The number 3.47 has 3 significant figures. There is a decimal place, so we would count this way. This number has 3 significant figures. For multiplication and division, we use whichever has the fewer number of significant figures. That's the 2. So then we go to all of our possible answers. Remember, we don't want to change the magnitude of the answer. We don't want just these 2 digits because that doesn't make sense. We know that 15 divided by 3.47 is not a really, really small decimal. We know it's around 4 point something. So here is the answer that has 2 significant figures, just like the 2 significant figures that we're limited to. All right, what we're going to do now is we are going to take a look at 4 examples. And basically what I wanted was an example for each operation. So we'll have an addition, a subtraction, a multiplication, a division example. Now, our first one is addition. Just so we are clear, when you're working with addition problems, and I want you to, if you need to, write this down. So for addition and subtraction, we look at the fewest decimal places. So let's take a look at the two numbers that we have. And I tried to line them up. That's why there's a giant gap here between that, because I wanted the ones placed lined up. So the number 2010, remember, we're not looking at significant figures. We're looking at decimal places for addition and subtraction. The number 2010 has no decimal places. It doesn't even have a decimal point. So 2010, we have 0 decimals. In the number 3.415, we have 3 decimal places. 1, 2, 3. Doesn't matter what order you count. It's just how many numbers are behind the decimal point. So we have 3 decimals. We look for whichever one is fewer, so that's 0. So first thing that I would like you to do, and you've been doing this for years, get your full answer. Type it into the calculator, get your full answer. So in this case, we have 2013.415 centimeters. So that's the full answer. However, we need to account for the significant figure rules, and in this case, we need to get our answer to have 0 decimals. So that means we're going to go to this point right here. We'll look behind it. It's just a 4. So our final answer is going to be 2013 centimeters. Now, it goes back to something that we said before. We can't report our answer to a level of certainty that's beyond our measurements. So in this case, when we have these 2 measurements, we can't report it to 3 decimal places because we only measured one of the 2 numbers to 3 decimal places. So the other ones we measured to 0 decimal places. So our answer can have 0 decimal places. Hopefully that makes sense. Okay, for our next problem, we have a multiplication problem again. So again, as a reminder, with multiplication and division, we're looking for the fewest number of significant figures, not necessarily decimals. So let's take a look at this one. We have the top number here. This has a decimal place. So we're going to count all of these digits going in this direction. 1, 2, 3, 4. So we have 4 significant figures here. Down here, this number has a decimal place. So again, we're going to count in this direction. We have 1, 2, 3, 4, 5. 5 significant figures. So in this case, our answer is going to be limited by this 4 significant figures. So when you type this into the calculator, you'll get an answer of 704.19456. This will have units of kilometers squared because it's kilometers times kilometers. So we're allowed to keep 4 significant figures. So 1, 2, 3, 4. We're going to stop right here. We're going to look behind it. It's a 9. Okay, so 9 means we're going to round up. So our final answer is going to be 704.2 kilometers squared. Questions on that? Again, remember that you are trying to maintain the magnitude of a number. If you have a number that's somewhere near 700, you shouldn't wind up with only a decimal, or you shouldn't wind up with something in the thousands. So be mindful of that. We're just rounding at the end to account for significant figures. Okay, we have one more example. So in our final example here, we are looking at a subtraction problem. So a reminder, for subtraction, we look at decimal places. This has 3 decimal places. This has 1 decimal place. That means our final answer can only have 1 decimal place. Well, the final answer that you get, if I take 0.682 and I subtract 2.3, I get negative 1.618 millimeters. In this case, I can only keep 1 decimal place, so I go to the first decimal place that I could keep, I look behind it, it's just a 1, so I have a final answer of negative 1.6 millimeters. Okay, so your homework for tonight, or for this week, if you're in cyber, is to look at this assignment. It's called Calculating with Significant Figures Practice. It's also found in the Lesson 3 folder on Schoology, so you could take a look at it there. What I'm asking you to do, there are 5 problems on there. I'd like you to try those 5 problems. I gave you lots of space so you can show your work. Please try and count up the number of significant figures and show that work as well. And then what I would like you to do is to submit that. That'll be one of the 2 assignments that we're going to submit. So we had the significant figures practice earlier, and then this assignment. And then we'll finish out this week later with an assignment on scientific notation. So at this point, this is what I would like you to practice. I will also be having an extra help session this week, so please be sure to check Schoology. All right. Thanks very much, guys.